And so Sydney, you're interested in learning rholang, I hear.
Yes, I am. Yes.
Rholang is a totally weird language. I mean, you gotta, it's going to be different from anything else you've ever experienced. It's really weird.
Okay, cool. Cool.
Okay, now I'm we're going to start out with rholang, and we're going to learn about the row calculus and how the language rholang relates to a very simple mathematical formulation that formalizes process orchestration. But the weird thing about it is it does everything at once.
Okay.
It doesn't do things in a sequential order unless you force it to do so.
Okay.
Okay. But we're going to start out with the developer, the rdev governance developer interface.
Okay. And
normally we run this on our own local machine.
Okay.
When we're doing development, but we have a shared, the rchain developer cooperative is running this machine, robot.net, where we run our common services and stuff.
Okay.
And we have an interface running here. It may not be up to date. Certainly at one point we'll show you how to update it, or how to update your own local host instance. Okay, so so the match statement we see here is this is sort of an empty process. Okay, if we go to check the balance on an account, we get the rholang code here to do that, and then we can connect your wallet, and it fills in the amount. And what we can see is the match statement says give this name to match one argument in the match statement. So if there's one argument in the match statement, it'll assign the name mygov rev address to that value. And there's no let x equal 5 in rholang yet. It is defined as part of the language, but it doesn't exist yet. And that's let statement is really syntactic sugar on the match statement. Now, if we put a more complex pattern here, we might have different alternatives. So this would be more like a select. If it matches one argument, do this. If it matches two arguments, do that. If it had a string or the value 25, whatever, whatever. But we'll learn more about the match statement later. For now, it just assigns the name. It matches one argument, and it assigns the name to a value, right? And then the only things in rholang are channels and processes. And a channel name is a process that represents itself. The number 5 is a process that represents the number 5. Okay, one of the innovations of the row calculus over pi calculus is it has the idea of names that are unforgeable. So we can make new names like return, which is an unforgeable name, which means that it's totally secure. It's totally private. Nobody can access it. It's local within the braces unless I share it. Now, if I share it with someone, I'm giving them the capability to use that name and access the value. Let's go back to select an action here. Oops, doesn't go back, reload the page. Okay, so if I make a new X, I give it a context where the name X is available. Okay, now I can write a value to X. Add the exclamation point in rholang is the way I write a value. X, right? Hello. And basically the only thing I can do in rholang is read and write messages. Oops, I need parentheses. Silly me. I'm not sure why, but I need parentheses. And there's one special thing in rchain where the first name I introduce is the result of an explore operation. So if I explore this, problem, syntax error, end of file, line 6. What did I do? It looks like I'm missing an end parentheses. and then brace. Why doesn't it do a new line? There we go. Obviously, our braces have to match. And we explore again. And we see we got hello. Isn't that nice? So let's create another value, another name. And we can send hello to Y. And we explore. And we get nothing. Okay. Nobody read Y. So besides writing, the other thing rholang, of course, is read. We can read it. We can read a channel. So let's read it. And we basically do use a wait for, which is a for. A for is not a loop. Everybody calls it a loop, but it's not a loop. For is a wait for. So we introduce a name. Z is what we're going to bind the value we read from Y. And then we're going to do some code. So when we match a pattern of one element in the channel Y, it's going to trigger this. It's going to trigger this code, and we can say we can write to X. We can write Z, and we can use the concatenate operator to concatenate. Plus is concatenation in rholang. World. Oops. Okay, and now we can execute this, but we'll get an error because line 7, syntax error. Y doesn't like Y. Y doesn't like Y. Well, okay. At the end of this brace, we have no operator between the for and the right to Y, and the only operator we have is the par. Run these two things in parallel. So it runs the for and the right at the same time. However, this is not going to be executed until something is written to Y first. So we're forcing it actually to execute line 7 before it executes line 5. Does that make sense?
Yep, I think so.
You think so? Isn't it ridiculously simple? No?
No.
But there's a lot to learn.
I don't think I understood why before we did this for Z to Y, why didn't new X, Y produce Y? Is that because X was not defined in any way?
I don't understand the question. I mean, this creates the unforgeable name Y, which, right, or we call it Y. It's an unforgeable name. Actually, we can't forge the name, okay? But we can call it Y for now.
Sure. But when it was just new X comma Y in and then Y hello, it didn't run. And is that because we were doing nothing with X?
We were doing nothing with. No, it's because the first variable that we declare is the result.
I see. Okay.
So the only thing it's going to output is if we write something to X, it's going to output it. If we write something to anything else, it's not going to output it.
I see. Thank you.
Okay. Oops. We go still. Name variable Z 413 is used in a process context at 512. Well, this is one of the foibles of rholang in that we're using a name in a process context. And we always send processes. Okay, hello quote is a process representing, it doesn't reduce to anything. Okay, if I put in par here, right to X 2 plus 2. Okay, 2 plus 2 reduces to 4. And then 4 is a process that is reduced as far as it can. 4 is a 4, period, right? Same thing with hello. Hello is a process that's reduced as far as it can be reduced. But we have to send a process and receive a name. We send a process to a name in rholang. And here it says, oh, gee, we're sending a name to a name. We can't do that in rholang. We have to send a process to a name. Well, we can cast a name as a process by putting a star in front of it. Okay, now, like the word hello, the unforgeable name Z represents itself, but as a process. That's a big confusion with rholang on our chain, actually. There are some implementations of a subset of rholang that don't give an error message. It's like doi, you wanted this to be a process, not a name. But rholang in our chain enforces it because it wants you to be aware of the difference between a name and a process. And that can take a long time to be comfortable with. Okay, so a variable Z used in a process context always means, oh, I forgot a star. Okay. Now we explore and we see if it works now. Aha! Now we can see that it got hello world, and it got 4 because we output it to X. It's considered part of the result. For an explore. Later we'll learn about deploy, in which case every deploy onto the blockchain. Explore doesn't change the blockchain at all. It does nothing on the blockchain. It just runs the rholang code. Okay, but it can be used for read-only functions. Suppose I want to read a value on our chain, but I don't want to do anything with it. Like I want to check my balance, but I don't want to pay to check my balance. I don't want to put another block on the chain to check my balance, right? Okay, be sure to chime in with questions here.
I will.
So we learned 2 things. We learned the read and the write, and we also learned the match. Okay, we could have put in something like, we could have put hello here. And we could have put message here. And we could have put in message here, except I'm going to get an error. I didn't get an error. I bound the name. Okay, I confused myself here. Okay, because message is matched against the process. Hello. Message is a process, not a name. Okay, and I could have put a star message here, and that would give me a problem. Name variable message used in process context on 7. Well, by saying that message that I'm making a process for message, I'm making it a name. So now I have to put a star here because I made message a name rather than a process. Is that confusing enough? Okay, so so I'm going to leave it as a process for now and see that it works. So it's a way of forcing a name to be a process, or a name. If that, I don't know. Probably we should say message is an identifier that can represent either a process or a name.
Sure.
It's confusing when I call it a name. It's an identifier for the process hello.
Mm-hmm.
If I put a star here, then message is an identifier for the name of the process hello.
Mm-hmm.
That's just an identifier. That's I think a good distinction to make. Okay, so that's rholang. Now you pretty much know rholang.
Okay, cool.
Let's look at an example. Let's see. We can look at the towers of Hanoi. You familiar with that?
I don't believe so.
You don't?
No, I'm not.
Hey, we're not recording. We don't believe it.
Yeah, we are.
Oh, okay. So the towers of Hanoi.
Yes.
Has some number of disks, with a smaller disk always on top of a bigger disk, and the idea is to move all the disks from the left peg to the right peg, using the middle peg as intermediate storage so that you never have to put a larger disk on a smaller disk.
Okay.
Okay. And so if we look at doing that in rholang, okay, we make a new variable result, which is where we're going to get our output down here. So we're going to send to the identifier result, which is a name. We're going to send any output that we want to see in our result, right? And the result is going to be something like this. It's going to be instructions on move the top disk from the left to the right, blah, 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 until all the disks are moved to the end post in the biggest one on the bottom, right?
Mm-hmm.
Okay, standard out, we don't really need to get into. This is a way we can write to the node log. Okay, and we can look at the log later. When you're writing your own R node, you're going to want to look at the log. You can see the log on Robot. We have a URL for that. But usually you don't need to look at the rholang log. It's only in case of some problems and debugging and things that you might want to look at the log. And this is called the power box function because this is outside of rholang. We're not sending and receiving a message inside rholang, we're actually sending a message outside of rholang. Okay, we're not sending, standard out represents a channel that's not an R node, not a formal row calculus channel. Did I confuse you there?
No, I think I understand that. You're just saying that
power box function. There's a way of connecting to the outside world.
Right.
And it's also used to access, internal R chain, R node things like blocks and things on the chain, because they're not really part of rholang. They're part of our chain, but they're not part of rholang.
Right.
So that's, we create the identifier standard out to write to the log.
Okay.
Okay, and then we create several other names. And I guess as we go along, we need these different names. Now we're going to create, we want to do a move operation. We want to move disks from one peg to another. So we're going to send to the channel move the height of the stack, and we say we have the height in the stack is 3 here. We could make it 4, whatever. And then height, the identifier height becomes associated with, refers to the process 4, right?
Mm-hmm.
Okay, so we're going to move 4 from the left to the right using the center as an intermediate place.
Okay.
And when we're done, we're going to send an acknowledgement.
Okay.
Okay, that's because everything happens at once in rholang. If we're going to have any order to things, we have to enforce that by sending messages, because that's the only thing we can do in rholang is send messages.
I see.
Okay. Now I'm making a contract. Now a contract is something new that we haven't discussed before, but a contract is really syntactic sugar on a persistent read, wait for. We're going to have a wait for, and the wait for is going to wait for the height left height so we're introducing a new thing here. @ from. Okay, and the @ does the opposite of the star, of the asterisk. It says the name of the process from. And that's basically so I don't have to put an asterisk in front of from everywhere I use it as a value. So as a process. So the name, now I could have, without the ampersand there, I could put the star in front of from everywhere I use it. @ 2. And so I'm going to move something from a post to a post using another post as an intermediate holding spot. And I'm going to return an acknowledgement. ACK. And what is ACK? ACK is a name I introduce up here. It's a channel, unforgeable name. Okay, so when I receive this pattern, and what is the pattern? It's just 5 arguments. So I'm going to wait for this pattern to be sent to this channel, which is move. Okay, so what did I do? Oh, so this for statement is equivalent, almost equivalent to this contract. The difference is this contract does a persistence. It doesn't just run the code one time when it gets this pattern. It runs this pattern every time. Every time we send 5 arguments to the channel move, it's going to run this code that follows in the curly braces. Okay, whereas the for statement here only reads it once. So if we send something to move twice, it's not going to do it. Now this is actually a persistent read, which is greater than equal instead of greater than dash. If I make this an equal sign, that's persistent read. But nobody ever uses that. Whenever we do a persistent read, people use the syntactic sugar. They make it a contract. Okay, so every time 5 arguments get sent to this move channel, this code is going to be executed. And this code is going to make another name, act1, so that it can sequence its own activities. And sometimes we see when we need act1, we add it to the new up above normally. We don't, we may not think ahead enough to realize we need an act channel. So here we use a match statement with more than one alternative. We use it like a case statement. We're going to match the height, which is 4, against the process 1. Well, it doesn't match because it's 4, right? So we're going to have this second case here, which is underscore. Well, it doesn't match an underscore. What is an underscore? Underscore matches any pattern. Okay, and I don't care what the name is. I could have called this, I could have given this a name, like not 1. Okay. Mm-hmm. Now I bound the name not 1 to whatever the height is. Okay. Okay, so since it's 4, it's not 1, and I'm going to do this case. And now I'm going to move 3 disks to the from, and the from is going to be the left. I'm going to move 3 disks from the left to the other, which is
the center.
Right. I'm going to move the 3 disks from the left to the center, using the 2 as the intermediate post. And when it's done, it's going to return act1. So here I'm going to wait for act1, because in order for me to make the next move, I have to finish the first move. Does that make sense?
Mm-hmm.
And when I finished the first move, I'd moved 3 disks to the center. Then I'm going to move one disk from the left to the right using the other as an intermediate. Okay, so I've moved the top, so I've uncovered a larger disk on the left. And now I'm going to move that to the two. Okay, and then when it's done, it's going to write to ACK1. Now I have to be very careful using the same name for an ACK channel because I have to make sure that they're serialized. Otherwise, I'm going to get some really weird bugs. Some people writing rholang will never use the same name twice because they're not sure, which thing's going to get executed if more than one thing reads the same ACK channel or has the same return channel. In this case, since we only get here when we read ACK1, we know it's empty and we can use it again. And then again, when we move the larger disk to the 2, then we're going to move height -1 from the other to the 2 using the from as the temporary. Okay, we move disks off of the from, well, off of the left. Okay, and then when that's done, we return a nil, an acknowledgement. Doesn't matter what we send to the acknowledge channel. Okay, and okay, so when we get down to 1, the last disk that we're moving, okay, we first move 4, 3, 2, 1, but we say move the top disk from the from to the 2, and we're sending to the log, move the top disk from the from to the 2. Now, what is log? Well, we introduced log here, and we can see that we have a contract log down here, which creates a list of all the things that we logged. So we have a little utility at the end of this that logs. We probably didn't need to complex this so much. One of the things the log does is it makes sure that everything comes out in the same order. We serialize everything by adding to the list and prioritizing it so that we get the list in a correct order, and that can become a problem. We can look at if that changes. And then we're done moving a disk. So when we get an ACK back that we've actually logged it, we send an ACK to a nil. And if we explore this, we can see the process. And if we make this a little simpler, say we do 2, height of 2, move the top disk from left to center, move the top disk from left to right. So the smaller disk got moved to the center, the larger one got moved to the right. And then we move the top disk from the center to the right. And that moves 2 disks from the left to the right. Okay, and similarly, if we do 3, whatever, we can verify that this works correctly in terms of moving the whole stack from the left to the right using the center as an intermediate. But you'll notice sometimes we use the right as the intermediate in order to uncover the larger disk. Okay, let's simplify this a little bit and take out log. Okay, what we did here was we wrote the list. Where did we write result? Oh, here. So when we received an act back from the move, we write the list to the result. That's kind of a little complicated. So let's just go right to the result here. So we're going to write this directly to the result. Now, the question I have in my mind is, are they going to come out in the right order if I don't use the log? And okay, so we're never going to get, we're not going to write two arguments to result. We're just going to write one argument, although we can see what happens there. But we're never going to get Act 1 back because sending to result, nobody's going to ever write to Act 1. So we're going to simply have to acknowledge ourselves and do a nil. Oh, does that make sense? Okay, when it was done writing to the log, it would get back an Act 1, and then it would acknowledge that the move was complete. Act 1. Looks like I'm messed up here. I hit a bug here. I'm going to do Control A, Control C, delete. I'm going to paste it back in here, and hopefully, I don't know why we have all these parentheses. I make this Act 1. Okay, because that result. Okay. So we're not using the log, but so we're going to always acknowledge this after we print the thing. And if we explore, we probably get an error. Act 1 on 11.9. Oh.
Is it because you spelled ACT rather than ACK?
Yeah, and because I really sent it to the wrong thing. If we look here, we can see it sent it to Act.
Mm-hmm.
Okay, not to Act 1, because Act 1 was never introduced. Okay, so what happened is we got this unforgeable name here. We got to the output. Confuses things. That's because we don't need this anymore. We don't need to write the unforgeable name here of it. But okay, so now if we do explore, we see we get the moves here. Now let's do it for 2 and explore. Top. Okay, left to center, left to right, center to right. Okay, we're always getting these in the same order. Thing is, in rholang, sometimes we have to be very, very careful to make sure we get things in the right order. And because we're getting an acknowledgement back each time here, I think we're pretty safe that these are always going to come out in the same order. However, today's Wednesday?
Yeah.
Okay, I have 1 o'clock, which is the members meeting. You can feel free to join us in this room, actually. A member Zoom hangout. So if I go to the collab, I probably have this in a number of places. Probably have it in rholang testing. We have ROCK. Should be in this channel, I guess, actually, now. You can call in robot testing. What? I don't have it. Paper? Well, let's look at paper more generally. And that doesn't give us anything. So we go to the, how do you spell scissors?
SCIZZOR.
SC.
I'm pretty sure it's ZZOR.
ZZ?
Oh no, I'm wrong. Do you spell SSOR? SCISSOR.
Okay. Let's look at this rock, scissors, paper example. Any questions about towers?
No, I follow.
Okay. So I make, you're familiar with rock, paper, scissors, right?
Yep.
Okay, so there's a winner, which is the result, because when we explore the first variable result, and then we have Alice and Bob, who are the players. And we have Alice send a rock, paper, and a scissors in parallel.
Okay.
But we send a rock, paper, and scissors to Alice in parallel. All right. And we do the same thing. We send a rock, paper, and scissors to Bob in parallel with sending the rock, paper, and scissors to Alice. They all happen at the same time.
Okay.
So now we have a bunch of wait fors here. We wait for a rock from Alice and a paper from Bob, and then we say winner Bob wins, paper over rock, right? And we wait for a rock from Alice and scissors from Bob, and we say the winner is Alice wins, rock beats scissors. You follow? Okay. So now we explore. We have Bob wins, scissors cuts paper. Bob wins, rock breaks paper. Bob wins, paper over rock. Oh, Bob always wins. Isn't he lucky? Let's play again. Oh, now Alice always wins. Explore again. Oh, now Bob wins one, Alice wins one. So now you know rholang.
Yes, I do.
Now, if you on this page is the learn rholang by example. And let me show you again. Learn rholang by example here,
okay.
Which you can go to and we can see things. And the next time we're going to go through and make sure you understand each of these things.
Cool. Sure.
Okay. And the other basic thing is object capabilities, which is different about the way the security model works. I'm not sure this example is the best, but in any case, we'll cover it in a future work study.
Okay.
And then I think after the second one, you'll be ready to actually contribute to some development in rGov. We're working on a chat capability.
Okay.
And there's something, it's going to strain your brain a little bit to understand the rholang of how that works. But the basic work is already done. Okay. So it's making an interface to it is not quite as challenging. It's still challenging, and there's a lot to learn. But
cool.
So we're starting in this room in 9 minutes. Now I'm going to take a 9-minute break.
Okay.
Any final questions or anything?
No, I appreciate your time and your explaining of rholang.
How do you feel about rholang?
Oh well, I think it's always I never know how long it'll take for me to start to look at a code and understand it and see what's going on. But I think I get it a lot more than I thought I would get it. So that's exciting.
You can always watch this video. Don't forget.
Yeah. But yeah, so far so good.
Awesome. Welcome aboard, and I hope
Thanks so much.
I hope you get lots of employment, and we change the world using rholang.
That'd be nice. Looking forward to it.
All right.
Cool.
Sydney, great to meet you. And,
yeah, nice to meet you. Well,
bye now.
Until next time. Yeah.